Coming back to the law of circuits, we are going to discuss about a very three important laws which are closely related to the electrical circuits. So what are all the components of electrical circuit? And this I would have given in my previous lecture during the introduction towards active and passive elements in an electric circuit. The circuit comprises of several ideal elements whose nodes are connected to various types, or else a circuit comprises of an ideal source and then ideal element followed by the load. Now there are different terminologies which are very closely related to electrical circuit. One is said to be node, the other is said to be path, the other is branch, and another one is loop followed by mesh. Node, it is quite simple. It is a meeting point. So a junction can be termed as node in an electrical circuit. What is a path? Path is a flow of current provided the current only flows in a closed path. So the circuit should have one starting point and it should have another ending point without any break. Coming back to the branch in an electrical circuit, it is path between two different nodes can be referred as branch. Loop, it is a closed path where, as we discussed, it has own starting point and the ending point without any break. Mesh, number of loops put together form a mesh. A loop that does not contain any other sub loop that can be referred as mesh in an electrical circuit. So with the reference to this electrical circuit and terminologies, we are going to discuss about three important laws. One is Ohms Law, followed by Kirchhoffs current law, and then followed by Kirchhoffs voltage law. Now we are going to discuss about basic fundamental law of electrical circuit called as Ohms law. This law states when an applied voltage or a potential difference is applied across the two terminals or two ends of a coil or two terminals of a conducting material, it is observed that flow of electrons constitute current which is proportional to the applied potential difference. So this statement can be validated that it states that voltage across two terminals of the conducting material is proportional to the current flowing through it, provided the condition must be at constant temperature. So coming back to this validation of this law, these laws are applicable only in linear circuit where it provides proportional change in current and then as well as proportional change in voltage. So when I represent this as del I, change in current, this as del V, this relationship must be a linear. So at this case only this law is acceptable. And as pure metals are good conductors of electricity, it is applicable for Ohm's law. But in case of non-linear circuits, such as electronic device characteristics such as diode, transistor, and then as well as SCR, this Ohm's law cannot be applicable as you cannot change the linear relationship of change in voltage and change in current are not observed. Coming back to the mathematical analysis of Ohm's law, having V and I, the statement gives V is proportional to I. On replacing this proportionality symbol with the help of equational constant, V is equal to IR, R is equal to V by I, R is represented in ohms. This is applicable in DC circuits. Coming back to AC, V is proportional to I, then V is proportional to IZ. Z is a combination of resistance and inductance, what we discussed in AC circuits in earlier lectures. So this relationship of impedance as summation of resistance and then inductance nature of the coil. Coming back here, inductance as the phasor relationship between voltage and current, which means that this cannot be applicable in AC circuit unless until if the impedance component is equivalent to inductance with low resistance. So but this law can be applicable provided if the inductance component is 0 and inductance is impedance is equal to completely pure resistance. So Z is equal to V by I. We can observe this linear property, but provided where in case of an AC circuit, this Z is equal to R is possible only in ideal cases. So that is the concept of Ohm's law. In continuation with Ohm's law, now we are discussing about another fundamental law called as current law, that is Kirchhoffs current law. This law was stated by the scientist Kirchhoffs, and he observed that current at meeting point is observed to be zero in a closed circuit. So what does the law states is the algebraic sum of current in a junction is referred to be zero. So what is a junction? That is the terminology what we studied in the fundamental of electric circuit, where when there are two branches or two or more nodes meeting at a point, that may be referred as junction. And he observed that current practically remains to be zero at junction. So the same law can be stated that current which is moving towards the junction will be equal to current moving away from the junction. So these are all the simple branches that carries current, and N is represented as junction. We can observe here the incoming direction of the current towards the junction is incoming and outcoming is represented in the form of arrow mark. So from the arrows, as per the statement, current flowing towards the junction will be equal to current flowing away from the junction. On equating this equation, the equation terms to be equal to 0. This was the statement that is given by Kirchhoff in current law, stating that algebraic sum of the current flowing at the junction is said to be equal to 0. Then another law called as Kirchhoffs voltage law represents the voltage direction. So the rise in voltage or fall in voltage can be observed between two ends of a coil in a conductor. With the circuit a closed network consisting of more number of nodes with many number of branches, it is always very complicated to determine the voltage drop and the direction of current with the basic fundamental laws. So by applying Kirchhoffs voltage law, power loss across various ideal elements, voltage drop and direction of current can be represented. So in order to represent all these mathematical equations in an electrical circuit, the final validation was given by the Kirchhoffs voltage law statement. What does the statement indicate means? Algebraic sum of voltage drop round a loop or a closed path in a mesh circuit in a specified direction is said to be 0. So algebraic sum of voltage drop represents either rise in voltage or a fall in voltage. Suppose it is observed that on the assumption when there exists a rise in voltage, it is always denoted by the positive sign. When there exists a fall in voltage, it is represented by the negative sign. Based on this direction of positive and negative, the direction of current is represented, or this can be taken as vice versa too. So according to this statement, consider an electrical network which consists of two sources V1 and V2 which are connected with various ideal elements, so that are resistance. Applying the equation of Kirchhoffs law as per the statement to the two loops mesh 1 and mesh 2, I can write the equation as V1. As it goes from minus to plus, it is observed to be rise in potential, so it is represented by positive sign. When current flows through the resistance, you can observe voltage drop across this resistor. So voltage drop as per Ohm's law, V is equal to IR. So as I1 current passes through resistance, by applying KVL, it is represented as I1 R1 and the negative sign indicates the fall in voltage. Similarly, coming back to this branch R3, it is common branch for both mesh 1 and mesh 2, and there is a possibility of both the currents to flow through the network assuming the directions. So in that cases, based on the majority on solving mesh, it is observed On solving mesh 1, I1 is said to be the majority current. So equation written as the both the current passes through, I1 will be dominating. So I1 minus I2 into R3, that gives the voltage drop across the resistor, and it is denoted as negative sign. So algebraic sum of the voltage drop, either rise or fall in voltage, is given as 0. That is the validity of Kirchhoffs voltage law statement. So on summarizing all these fundamental laws of electric circuit, the basic mathematical analysis behind all these laws are to determine the different electrical parameters, such as potential, to find out the potential drop across a resistor, to find out the direction of current, to determine the power exhibited by a resistor or dissipated by a resistor. Thank you.